Building a simple AI agent prototype locally using standard APIs is straightforward today. You can string together a basic script for an impressive result. But taking that local agent and scaling it to run reliably in a production environment for a real business introduces a new set of engineering constraints. Many developers fall into the prototype illusion, the false belief that a linear script that works for a single user will gracefully scale to thousands. It rarely does. This chart maps the first catastrophic symptom of the prototype illusion. The moment multiple users hit a fragile system, infrastructure costs spike aggressively. The second symptom is system paralysis. Agents get trapped in infinite reasoning loops, halting execution while generating streams of error codes. The third is catastrophic memory decay. Halfway through a complex, long-running task, the agent simply forgets its primary objective. Why do seemingly functional agent prototypes predictably crash or hallucinate the moment they are deployed at scale? True production scaling requires diagnosing and engineering past three distinct architectural bottlenecks: loops, context, and orchestration. Failing to bridge the engineering gap between prototype and production turns what should be a business asset into an unbounded financial and operational liability. We begin with autonomy. An agent's baseline value comes from its ability to plan a task, execute it, reflect on the result, and try again if it fails. This cyclic workflow diagram represents the standard react, or reason-act cycle. This is the basic architectural mechanism enabling that autonomy. In a perfect scenario, this loop completes successfully on the first or second try and efficiently resolves the user's prompt. But in production, external tools, databases, or APIs will inevitably fail to respond to the agent's request. The system attempts to recover. The agent path loops back aggressively to retry the exact same failed step over and over. This introduces our first major bottleneck, the silent cost multiplier. An unchecked reasoning loop operates blindly. It will generate dozens of high-context, expensive LLM calls in a matter of seconds. This digital billing counter illustrates the financial drain caused by those runaway API token allocations. A single user query can quickly cost hundreds of dollars. Probabilistic LLMs do not have inherent stopping mechanisms. When they are confused by an unresponsive tool, they will simply keep guessing. The mandatory engineering solution is building hard-coded circuit breakers directly into the system code. A circuit breaker tracks cycle counts and forces a deterministic halt if a loop exceeds a set threshold. Instead of looping infinitely, it safely returns an error state. Without strict circuit breakers built into the orchestration layer, granting an AI agent autonomy is equivalent to handing it a blank, unlimited corporate credit card. The second major bottleneck is managing conversational state and historical data over time. Most prototypes rely on naive state management. This is the practice of appending raw, complete chat history into the LLM prompt on every single turn. We can visualize an LLM context window as this finite geometric space with a hard token limit. As the agent takes more steps, the token count inevitably rises, consuming the available space block by block. Eventually, it hits a critical overflow point. The container becomes bloated with intermediate data. This structural failure is called context decay. Context decay has three mechanical symptoms: inference speed plummets, reasoning accuracy degrades, and the model loses attention on its primary objective. Paying for larger 1 million token context windows only delays this failure. It does not solve the underlying architectural flaw of passive storage. The true scaling solution requires implementing custom cognitive memory engines. A cognitive memory engine operates by actively ingesting linear blocks of history and programmatically summarizing them. The engine prioritizes and archives this compressed data. It feeds only the most relevant, highly dense context back to the inference engine. At production scale, memory cannot be a passive storage container. It must be an active compression algorithm to prevent systemic AI amnesia. This brings us to the final and most complex bottleneck: orchestration, the method of managing state across a multi-agent system. Basic orchestration frameworks exist and are excellent for rapid prototyping or simple task delegation. This visualization represents the structure of simple frameworks like CrewAI, which rely on a loose, team-based layout. While this non-deterministic structure is easy to set up, it lacks the strict programmatic control needed to manage complex operations predictably. Mission-critical business systems cannot run on probabilistic delegation and hope. The enterprise standard for orchestration is graph-based determinism, utilizing orchestrators like LangGraph. Here, we see the architectural shift to graph-based state machines. Every action and transition is mapped logically. Programmatic state management allows developers to build cyclical workflows while tracking the exact state of the system at any specific millisecond. This architecture enables hard human-in-the-loop checkpoints for high-stakes enterprise actions like deploying code or executing trades. Forcing the agent to pause for mandatory human approval ensures safety and compliance. Migrating from a prototype to a production environment requires abandoning loose agent delegation in favor of strict programmatic state machines. By solving these bottlenecks, we can reveal the unified blueprint of a production-grade AI system. This final diagram displays the complete Zev IQ AI architecture. It utilizes LangGraph state nodes guarded by hard-coded circuit breakers, all feeding into a custom cognitive memory engine. Scaling AI agents is a rigorous software engineering discipline focused on architectural oversight rather than prompt engineering. Leaving unoptimized probabilistic loops in a production environment will inevitably drain operational budgets and break user trust. Bypass the prototype illusion. Visit zeviq.co.uk today to book a free technical AI systems audit for your business. We are Zev IQ AI. We build smart systems engineered for infinite scale. True AI value lies in the architecture.